Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on how to calculate the molar mass of compounds. Alright, so the molar mass of elements is found on the periodic table, so there's nothing we need to really calculate there. It's just if we have more than one of that element, or if we have a compound, then we need to add together the molar masses of all of those elements in that compound to get the molar mass. Alright, so all of these values down here, previously we called them atomic weight, now we're just going to refer to them as molar mass. So this is the mass of 1 mole of any element. So if I'm finding the molar mass of an element, I just find it here on the periodic table, and bada bing bada boom, I'm done. If I have a compound, then I take all the elements in that compound and I add the values of those elements together to find the total mass of that compound. All right, so let's look at some examples here. So we'll start with iron. The symbol for iron is Fe. So if I go to my periodic table, I can see that Fe is here. So Fe has a mass of 55.85. The molar masses are the numbers on the bottom, not the numbers on top. So 55.85 is the molar mass of iron. Right, and then the units that we use for molar mass are grams per mole. Hooray and huzzah. All right, let's look at another. Here we have oxygen. So oxygen is a Brinkelhoff element, so if we're looking at elemental oxygen, it is going to be O2. And in this case, since I have 2 oxygens, I'm going to take the molar mass of oxygen and multiply it by the number that I have. So I have 2 of them, and the molar mass of oxygen is, over here, and it is 16. So 2 times 16 is 32, so I have 32 grams per mole. All right, let's look at a compound now. Here I have NaCl. So NaCl is made up of 2 elements. I have Na and I have Cl. So in this case, I just have one of each, so I just need the molar mass of Na and of Cl. So I go to my periodic table and I see that Na is here, it is 22.99, Cl is here, 35.45. So 22.99, 35.45, and then I just add these together, and I get 58.44, and then my unit here is grams per mole. All right, let's look at some compounds that have more than one of each element. So here I have K2Cr2O7, so I have 3 elements here. I have K, I have Cr, and I have O. So I have 2 Ks, I have 2 Crs, and I have 7 Os. So what I'm going to do is I'm going to multiply the number that I have by the molar mass of that element. All right, so 2 times molar mass of potassium is 39.1. So that equals 78.2. Molar mass of chromium is 52. If I multiply those, I get 104. And then the molar mass of oxygen is 16. And 16 times 7 is going to be 112. So now I just add all of those together, and I get a total of 294.2 grams per mole. All right. If we have a compound that has parentheses, I have to distribute the number outside the parentheses to everything inside the parentheses. So the S gets multiplied by 3 and the O gets multiplied by 3. The aluminum stays as it is because there are no parentheses around it. So aluminum, I have 2 Als. S's, I have 1 times 3 is 3. Oxygen, I have 4 times 3 is 12. Molar mass of aluminum is 26.98. So when I multiply that, I get 53.96. Sulfur is 32.06. So when I multiply those, I get 96.18. And oxygen is, of course, 16. So when I multiply that, I get 192. Right? And then I just add those together, and I get 342.14 grams per mole. All right, let's do one more. So here I have NH4 in parentheses. So this 2 distributes to the N and to the H. So I have N, I have H, I have C, and I have O. So I have 2 N's. 4 times 2 is 8 H's. I have 2 C's and 4 O's. Molar mass of nitrogen is 14.01, so that gives me 28.02. Hydrogen is 1.01, that gives me 8.08. Carbon is 12.01, so that gives me 24.02. and oxygen, of course, is 16, which gives me 64. I have 4 things that I'm going to add together here to get the total mass, and when I do that math, I get 124.14 grams per mole. You'll notice that I didn't round. We're not rounding for any of our molar masses. We put in the numbers into the calculator just as we got them here, and then we use all of the decimal places that it gets us. The periodic table that we use in class, all of those molar masses have a maximum of 2 decimal places, so your answer will have a maximum of 2 decimal places, so you don't need to round anything at all, you just leave it exactly as it is. So, this has been another episode of Chemistry with Wikipedia Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.